I'm sure there'll be a few more folks coming in. My name is David Pott. I'm with the U.S. Fish and Wildlife Service. I'm on the program committee. So this is part 2 of Shorelines, Oceans, Marine Ecosystems, kind of a coastal focus and in particular sea level rise and coastal carbon sequestration. So I'll go ahead and introduce Stephen Crooks with Environmental Science Associates. They've developed a really groundbreaking system to measure carbon for coastal wetlands. It's a very exciting project. So Stephen, take it away.
Thank you, David. Well, surely the governor has a difficult act to follow. So, but in the 3 minutes since then, I sort of rewrote my talk. And so I am going to talk about the Snohomish and a lot about the results there. But what I'm also going to talk about at the beginning is some of the, how we communicate this kind of science to people at different levels of government, and some of the discussions that we're having there to try and take this concept of blue carbon, which reflects the role of coastal wetlands within the within the carbon cycle, within the frame of climate change mitigation, and how we try and bring that into existing and new developing policies. And right now, it's a topic of a lot of interest. You know, since 2009, it's really bubbled up. It's now being considered with a lot of interest under the climate and the present Climate Action Plan, because it touches upon mitigation, adaptation, and global impact, and it's trickling through a large number of policy communities. It's a kind of schematic of, you know, what are we trying to do? I'm going to go to the very broadest scale. You know, there are simple conceptual models like this to describe how we want to interface with policy and with legislation to drive environmental change. And in the world, there are drivers of change, climate change, sea level rise, food production, urbanization, etc., which lead to pressures, which we feel as a population, it leads to a state change in the environment and a decline in environmental quality, which leads to impacts, which we feel as a community, either economically or in terms of health, or in terms of moral values, as the governor was describing, which leads to a policy response, which we hope leads back to a virtuous circle of improved environmental conditions. And beneath this conceptual model, there are models, more complex models and analysis that we can bring to bear, from benefits analysis to environmental impact to vulnerability analysis. And we try and bring those all in together to try and inform this policy discussion. Now, when we think about adaptation, when we think about restoration in this world, what we do is we take an environmental system which has been degraded, and we want to improve it. We want to improve its resilience to climate change and to everything else. But recognizing that the world is changing, particularly with climate change, we have these moving baselines that we, as the environmental scientists, are recognizing, be it sea level rise. We recognize that the world is changing, things move around. Now, that's a difficult concept quite often with planning frameworks. Now, the people working in the mitigation side and the carbon side think of the world in this way. What they are trying to do, and what we're doing a very bad job of right now, is reducing greenhouse gas emissions. And what we're trying to do is, you know, work on the transport sector and work on the energy sector. But increasingly, the discussion is going to how do we incorporate landscapes, managed landscapes, natural landscapes into the climate change mitigation framework. Is we want to improve things relative to a baseline, whatever the baseline is. And it might be a system right now, say an agricultural field which has got no carbon sequestration, and you do a project and it now starts sequestering carbon. It could be a project where you're having ongoing emissions from a peat swamp, for instance, that you've drained in the Snohomish Estuary or wherever. You've got ongoing emissions and you want to reverse that. And the improvement that we're looking for is the delta between the baseline and the with project or with policy condition. It could be that you've actually got an improving condition and we want to make it even better, or you've got a declining condition and you want to make it less worse. That's what we're trying to achieve with carbon management. And we have a lot of work to do. Now, there's been a lot of work over the last 20 years in terms of bringing forests under various climate change mitigation frameworks. You'll have heard of REDD+, concepts like that. Wetland scientists around about 10 to 15 years ago said, hold on a second, a lot of carbon in the world is held within soils. We should be looking at peatlands as well. And so what we're trying to do here is we're trying to move forward and take the concepts developed on above ground biomass and the concepts developed on terrestrial peatlands and move down slope into the near shore and coastal environment to include mangroves, tidal marshes, and seagrasses. Because in these systems, a lot of the carbon is held within the soil. Now, how much carbon? Well, we were part of a study. There was a number of us, including Linwood Pendleton, who was chief economist for NOAA at the time. estimating what the emissions are around the world. And we came up with a conservative estimate from seagrasses, mangroves, and salt marshes. Somewhere of the order of 450 million tons of CO2 are released each year from destruction of coastal wetlands or ongoing emissions from historic converted wetland soils until that organic carbon is fully released. Our error bars are very wide. It could be as low as 150 million tons. It could be as high as a gigaton. That would place us about 450 million tons is about the emissions of California each year just from degraded organic soils and coastal systems. And that's a number we want to try and improve. But that number is of the order of 10% of total deforestation in the world. The biggest thing we can do is conserve existing wetlands, protect them from destruction, but restoring wetlands also has its benefits. Now, that's the climate change mitigation side of it. What we're not trying to lose sight of as well is that if you restore a wetland for climate change mitigation benefits, you have an adaptation, you have an ecosystem benefit as well. This is just a simple graphic. These fish are the same age. These fish here were grown on a floodplain with wetlands for 3 weeks. These in a wetland, these in a river without wetlands. Same age fish. Wetlands are important for so many reasons. So the approach that we've been taking is to try and work at multiple levels of governance. We were lucky we went to the UNFCCC, the climate change negotiations in Cancun, and we've been operating there each year since. And we've been interacting with various climate change negotiators, bringing to their attention the importance of wetlands in the carbon cycle. And they've got to the point now where they're interested in the science that's coming out, the science is starting to coordinate, but they want us to go back to the local environment and show we need demonstration projects on the ground which provide defensible quantification and show that you can work with communities. It shows that you can develop legislation to enact these types of projects so that they can build more policies at the international community level. So we're trying to operate across these 3 levels of governance to develop policy at the top and help develop projects at the bottom. And in the middle, national governments, the federal agencies of the US are very interested in this. The White House is asking where should federal agencies right now be spending their money to try and help with these kind of issues. We've had a number of successes. In 2010, our main message was, where is the IPCC on this topic? And in January of 2011, we got a phone call from the IPCC saying, well, actually we were going to look at wetlands. They do the National Greenhouse Gas Accounting Guidelines, so that forests, agricultural land, settlements, each nation provides their accounting inventories each year. Wetlands were missing from the 2006 guidelines, which is the most recent. They were revisiting this, and in 2013 said, we were going to do wetlands, maybe we should do coastal wetlands as well. And so we got that included, and in November, December last year, the IPCC met, approved the guidelines, and we released them, the IPCC released them in December of 2013. And the guidelines now include procedures and approaches for accounting for greenhouse gas emissions for land use change on wetlands. And Chapter 4 includes coastal wetlands, mangroves, seagrasses, and tidal marshes. So if you destroy a salt marsh, or you put a salt marsh back, there are procedures for accounting for those emissions. And the EPA at the federal level, and hopefully the state level soon, will be including those emissions and removals within their their national accounts. Another success is that we've been working with the verified carbon standards, one of the voluntary markets. What we're trying to do is change policy, change management activities, but also provide tools through the financial markets to try and help move things forward towards wetlands restoration for climate change mitigation adaptation benefits. The VCS represents 52 to 58% of all voluntary carbon trades in the world. In 2012, they rewrote their constitutional document. They recognized all these different types of land use as being potential project activities. And in 2012, they included wetlands restoration and conservation as being eligible. You can come to them with a methodology and a project for potential carbon credits. To get that, you need a methodology. So we're in the process of right now, working with Restore America's Estuaries, to write a methodology which is expected to be released in early 2015. It's under review right now for the VCS, that outlines the procedures for greenhouse gas accounting for all these activities in coastal wetlands. So potentially, if you're restoring by re-wetting, breaching a dike in the Snohomish Estuary, or improving sediment supply in another part of the system, you could develop a project that could be recognized under the VCS for carbon accrediting. Right now, the Californian cap and trade system is looking to expand its process and is considering how to include wetlands in the future. So hopefully, if there's a cap and trade system developing in Washington, this can also be included here. We're developing guidelines. What keeps me up at night right now is that in just a couple of months, we're producing guidelines for the United Nations Environment Program on guiding principles for delivering carbon wetlands, coastal wetlands carbon projects. And these are overarching principles. So, there are people developing carbon projects, there are people working in wetlands restoration. How do we marry these things together to avoid making early mistakes? And hopefully that's going to be coming out in this December. And that brings us to the Snohomish. So the policy people are saying we would like demonstration. We would like to see that this is operational in the field and it can be achieved. How big are the numbers, really? One of the areas that I've always felt was really had a lot of promise is the Pacific Northwest, in part because of their forested wetlands and the transition down to the coastal system, in part because of its resilience to climate change, and in part because of the energy that's already developed here within the community about tackling climate change. A group of us came together. Restore America's Estuaries, a national nonprofit, which interfaces a lot with policy people. Our consultancy group, Environmental Science Associates. John Ribsig's group at Western Washington University, who specialize in wetlands and soil analysis. And Earth Corp, a local nonprofit. And we were funded by NOAA Habitat and Conservation, Boeing, and the Wildlife Forever Fund. And we looked at the Snohomish Estuary to try and get a sense of how much carbon has been released historically, how much carbon could be put back again with existing projects that are already planned and being implemented, and what would happen if we extended that, and what would happen with sea level rise. The estuary represents nearly 5,000 hectares of drained wetlands. It's roughly 29% of the total wetland loss of Puget Sound, and right now there are 1,353 hectares of restoration planned or being implemented in the Snohomish. You'll all be very familiar with these graphics, so I can move quickly. This is what the Snohomish used to look like. The dark green hatching was forested to shrub, tidal wetlands, going down into emergent, which is the green. And here we are now. This is the same estuary area. Different types of agricultural land use or abandoned agricultural land. We're now in increasingly a mosaic of either wetlands such as EB Island, which were breached about 40 years ago naturally, to wetlands which are being brought back online, like the Quilute Project, Smith Island, Union Island, and then further upstream. So there's a lot of existing projects that we can work with here to understand what the potential carbon budget might be, and what the value is really to the society of doing it from a climate change mitigation point of view. What we included was an assessment also of what would happen with a sea level rise of 1 meter. And this is the boundary. The system is resilient to climate change for a number of reasons from a landscape perspective. The slope is excellent. You have a gradual slope going all the way up the system. You have a very high sediment supply which comes down the rivers and which helps maintain wetlands as they build against sea level. And you have very vigorous plants in this system, which I'll come back to. An additional parameter that makes the Snohomish very attractive, this is what's called a hypsometric curve. Here it's an area to either volume, it's an elevation against area or volume relationship. And the curve, my thing's dying. The curve represents the topography. That's, thank you. That one there? Thank you. So the curve represents the topography. The dark green area there represents the elevation which vegetation colonizes. And vegetation coming in is very important from a resilience point of view for marshes, but also in terms of a carbon sequestration point of view, because this is where most of your carbon sequestration takes place. So we see here, for instance, that all of these drained wetlands, the nearly 5,000 hectares, 1,000 is below the elevation at which vegetation would come in, so would require mineral sediment to build it up. But then once you get to this elevation, there's all this area, all of this volume would be filled with building marshes, which would sequester carbon. And then with sea level rise, if those marshes stay in the same location, then all of this volume will also be filled. And if they migrate back, then some of this volume will be lost again. So by just using, if you know the density of carbon within the soils, which can be derived from field measurements, it's the organic carbon content against the dry density. You can, by a volumetric approach, you can calculate the amount of carbon that will be sequestered, and through time, restoration. And here's some of the data that was collected by John's group. This is the topography of different sites that were sampled, natural wetlands. Natural wetlands naturally build up to mean high water. Restoring wetlands build up through the profile, and here we have some potential future restoration sites. Here is the amount of accretion taking place on these sites and some of the carbon sequestration rates. Typically, as you find along the west coast, that carbon sequestration rates in natural wetlands at equilibrium with sea level rise is around about 100 grams of carbon per meter squared per year. That's around about 4 tons of CO2 per hectare per year of carbon accumulation. EB Island, which was breached 40 years ago, is building faster than that. It's actually sequestering around about 4 tons of carbon, or 12 tons of CO2 per hectare per year, which was one of the highest numbers that we observe in natural systems. And part of the reason why EB Island, which is representative of many of the parts of the estuary, is so efficient is because of the plant species here. These bulrushes just suck up carbon and put it in the ground and build up soil. Similar experiments have been going on in the Sacramento Delta in California, just on managed plots, are building soil at 2 to 4 inches per year using similar species. So it really does suck carbon out of the ground. So it adds to the resilience of these systems and helps remove carbon dioxide from the atmosphere. Now, skipping to some of the results, how much of this is actually taking place? The planned restoration projects, 1,353 hectares, would sequester over the full life of the project around about just over 1.1 million of CO2. So that's over maybe a 100-year time frame. We don't quantify the rate, we quantify the extent. If you add in sea level rise, that would sequester an additional 1.3 million, giving a total 2.5 million tons of CO2 sequestered by projects already ongoing. That equates roughly to 500,000 cars over the entire life of the project, or 5,000 cars each year for 100 years being removed by that project. Some more key results. If we would expand the restoration project, if other landowners wanted to engage in this kind of activity, what would we see? Full restoration of the entire system as it exists right now would sequester around about 5 million tons, 4.5 million tons over the life of the project. An additional 4.5 million tons with sea level rise, reflecting the vigor of this system, removing just under 9 million tons of CO2 just within this estuary, which equates to 1.6 million cars over 100 years, or 17,000 cars just over 100 years. So not really big numbers, but when we look at doing restoration in different parts of the country, different parts of the world, each bit adds up, and it's additional to all the other ecosystem services that we get. So, as a last parting comment on what the governor was saying about connecting different experiences together, there's a lot of blue carbon projects building up in different parts of the world, be it Guyana, or the Middle East, or Indonesia. We can be doing more projects here as part of this kind of process. What we really need now, this is a scoping level exercise that we just did, is really to get into the science more, understand the emissions from the drain soils, which we didn't get into, understand the methane emissions, understand the sea level response aspects. We should be looking at what we could be done in other parts of the state as well. And I think in time, these kind of numbers will be integrated as part of a full landscape assessment of how we manage our landscapes. And in time, will be integrated into cap and trade systems and other policy and management frameworks. Thank you.
Thank you, Stephen.